Hi, everyone. For those of you that don't know me, my name is Lance Eisen. I am Chief of Operations for NORMI, which is the National Organization of Remediators and Mold Inspectors. And one of the things that we do in the IAQ or indoor air quality industry is we're always looking at evaluating new processes, products, methods, testing results that are out there and the way that that impacts our industry and our members. And we're always trying to get them the latest and greatest information that's out there. So because of that, Best Living Systems and their product line, which is largely based on what's called MCI, multi-cluster ionization technology, they actually commissioned a lab out of Florida to do some efficacy testing on the MCI technology and how it works on microbial loads, different types of microbes that are in the air and on surfaces that we normally deal with in our industry. So we're fortunate tonight, or for this presentation, to have Dr. Rajiv Sahay with us. He's from ED Labs, and I'm not even going to try to explain his credentials. I'm just going to let him briefly talk about himself. I actually did a little research on you, Doc, and it's quite impressive. So I'm going to let you speak. I don't want to shortchange you about that. So I'd like to introduce Dr. Rajiv Sahay, and please take a few moments and just let us know about you and your background and about ED Labs, and then we can get into what we did with Best Living Systems.
Hello and good evening to all of our viewer and participants. Myself, Dr. Rajiv Sahai. I have a PhD degree in aerobiology, and aerobiology is sort of a backbone for indoor environment quality because aerobiology itself is a mouthful and it encompasses almost all different field of science, including from physics to biology. So nothing in between is aloof from aerobiology. So one aerobiologist is supposed to know all these sciences because that's what we practice, because thing which you don't see or in the real world, if you don't see with your naked eye, that's what our expertise is. That's what I do. I am practicing indoor air quality for past 3 decades, almost 3 decades. And I'm also certified indoor air quality practitioners. And that is also a very good practicing field in the science for the society. And that's what we do. I have analyzed or supervised more than 500,000 different environmental sample collected from air, surface, or liquid kind of material. And my expertise is including bacteriology, mycology, indoor air quality, industrial hygiene, product testing, etc. Right now, I am the head of the laboratory operation as a laboratory director with a firm called Pure Air Control Services, and the name of the laboratory is Indoor Environmental Laboratory (ED Lab). That in indoor diagnostics laboratory. That what we do for like indoor air quality. Our lot of the client is for the indoor air quality kind of investigation. We do product testing. Uniqueness of this laboratory is that we have a product testing capability. We can do in the laboratory as well as we can do in the real world scenario. So we certify and test various kind of product, and our reach is all around the globe. We have served as far as in Asia, and we always, like, in the domestically, we have served almost all the states of the United States. So that is kind of our credential, and this laboratory is also certified or accredited with A2LA, and we are also certified by New York Department of Health. Department of Health has a program called as ELAP, Environmental Laboratory Accreditation Program. This laboratory is also enjoy the privilege of ELAP. We are also CDC Elite Laboratory, which is a special program for doing the Legionella testing in the environment. So our laboratory is also certified by that under that program through the CDC. And we are also participant of the American Industrial Hygiene Association program, PAT program. So we have both credential for doing the bacteriology, mycology, and the direct microscopy, meaning identification of the mold of a spore. I myself also designed and evaluated a product called as BioScan, which is typically used by a lot of industry folk for testing the mold on the surfaces, and that is a very good test for assessing or evaluating of any environmental surface, especially indoor environment surface for the mold or the growth of mold, and that is being well received. And I have analyzed myself more than 10,000 those samples. So we have a lot to say. I'm not going to kill the time to just keep me myself introduced. So I would like to just be here, and it's my privilege to be today in this meeting, and I would try to assist and share my experience and expertise with you all.
Well, I appreciate that. And as you can see, the listeners here, this is why I did not introduce you any further. I needed you to say who you were, because I would just be reading off lists and lists and lists of your qualifications and your background. So thank you for doing that for us. Greatly appreciated. So here's what this is all about tonight. Best Living Systems reached out to you and commissioned you to do a study on the MCI technology's effectiveness on microbes. And with that, I believe the organism that you picked for this was Staphylococcus aureus, if I pronounce that correctly.
Yes, the Staphylococcus aureus is a bacterial organism, and that was the organism chosen for that particular study which you are referring to.
Okay, well, I'm going to let you talk about the study, and let you explain it to our listeners. Basically what was done and the effectiveness of the MCI technology, how it actually worked on the different organisms that you tested.
Very good. So MCI technology is evaluated, or it was known, or you can say efficacy of this entire system in the microbes is very crucial, because the intent of the MCI is to provide the cleaner air without free from microbes, so that you can have a healthy living. So when I was approached the MCI, first I asked that what the goal and intents are, and that's what I had just said you, that the intent was to figure it out, that how effective it is against the microbials. So MCI, to those who are not familiar with that, I just want to capture two sentences for that. It is ion-based technology. Ion is nothing but, everybody understand that some of the particle in this universe is charged positively, some of them are charged negatively if you go on the molecular level. So the positively charged molecule and negatively charged molecule, they have their own advantage and limitations. So based on that, that is the bone of the technology. Based on that, the refinement, and then the multi-cluster ionization technology is one of the technology which is play with the ions, and then ions is in general is going to work on the microbes, and that is going to be lethal. That is the concept. So that if you have certain kind of problem with the microbes, bacteria, mold, viruses, etc., the intent here is to find out or figure it out that how effective it is. So that was the prime goal of that test.
And what did you find? I mean, cutting to the chase as to how it was, because that's what our listeners are really here wanting to know. How effective was the MCI technology on the Staphylococcus aureus organism?
Yes, that's a very excellent question. And the way the test was set up, our intent was to figure it out that, as I said you previously, that how effective it is, what it takes MCI to clean the environment, or how continuously the MCI is working so that you can breathe fresh air. So to prove that, first of all, what we did, we have created created an environment almost like an office environment. And then our intent was to figure it out that how effective it is, like you said, if XYZ number of organism or concentration is in that room, how long does it take MCI to get rid of that or inhibit those microbes, microorganisms? So the test protocol was very simple. I'm not going in a technical detail. I understand that many of you are not microbiologists. So I want to give you a real good information, real world information, so that you can understand that what we did, and what we are saying, why we are saying that. So the goal was to find out how effective it is on the microbes. So first of all, we have chosen a microorganism from the bacteria class. Why we have chose that? Because that is omnipresent. It will be like, from your workplace to your environment to our hospital to your school, you can name it. You can find staphylococcus everywhere on one side. The other side, this staphylococcus aureus bacteria can be turned in the superbug because it sometimes turn as an antibiotic resistant. So it is very hard to clean or get rid of that bacteria. So with that intent, we have chosen that organism, and afterward what we did, we have made a solution of that bacteria, which is billions and billions of cells per milliliter was involved there, and then we aerosolize that bacteria in the environmental chamber so that the bacterial chamber or the environmental chamber is populated with the bacteria. So what we did, we have first make an air sample after aerosolization to figure it out that how much bacteria we are throwing or we are aerosolizing in the room per liter or per cubic liter volume of the air. So our initial reading goes, and it looks like it was over 474 millions, bacterial colony over that were isolated. So it means that we have started the test from that concentration, and we didn't apply the MCI. We let it go naturally to see the sort of natural decay rate, that what happened, what is the fate of the bacteria over the hours. So we have set up this experiment for 180 minutes, and that is obviously about 3 hours if you turn in terms of hour. And then we start studying the behavior of bacteria under the natural sedimentation, because the aerosolization of the organism, depending upon its buoyancy, is going to be settled down. So what we have noticed that when we have started 474 million of bacteria, after 180 minutes, there was still 510,000 bacteria, or greater than 510,000 bacterial colony forming unit was existed in that room. So that sort of given us a curve that what happened over the period of 3 hours. Now we have set up the other experiment, just making everything similar, like all the condition, laboratory condition or prevailing condition was almost similar. But this time again, we have isolated, we have aerosolized the bacteria, and we isolated again, and then we find it was again over 445 million colony forming unit per cubic liter volume of the air or so. And then we start studying the bacteria, what happened, the bacterial fate in over the 3 hour period. But only difference we made in this experiment or this set of experiment is that we have put MCI on work. And then we start noticing the behavior. And I'm pleased to inform you that about 120th minute, almost 99% bacteria is gone that period. So within 2 hours, 99% bacteria is gone. Basically, you left with about 278,000 colony forming of bacteria. So 98% is gone. But if we go progress a little bit more further, then almost 100% bacteria is gone. So between 200 to 300 thousand colony forming bacteria is also vanished, because then we start thinking what would be the reason, because the bacteria lasted 3 hours in the previous set I said you, but in after 2 hours the bacteria is very sharply decline in the concentration, and approaching the 300 mark, it was 100% gone. So it means that the instrument which we have put in the chamber was doing something to the bacteria. That's why that bacteria weren't able to survive. So that tells me that if we can do this engineering change in the building and put the MCI, then the microbes or the overall concentration of microbe is going to decline, or this is going to be achieve 100% cleaning in terms of this particular organism, because we have tested the Staphylococcus aureus. So we can say the Staphylococcus aureus is concentration is going to be 100% clean if any Staphylococcus in other way in the environment is going to take taken care by this MCI technology.
Wow. So I mean, just summing that up, I mean, that's there was a lot of data there, and that's pretty impressive the way that you worked out that experiment. But in summary, it's basically saying that you had over 450 million colony forming units in both tests. And with the MCI turned on at the 3 hour mark or the 180 minutes, you had 100% reduction or kill rate, I guess, to that organism.
Yes, yes, that's the right interpretation. Because had this MCI not there, then again I told you that, like, the concentration of bacteria under the natural sedimentation rate was going, but it was much slower and much lesser because you were not able to clean the 100% bacteria in the room. But when you introduce this system in that particular room, then you have achieved like 100% cleaning because there wasn't any bacteria left after 3 hour period.
Wow, that's been impressive. Uh, I, I mean, almost speechless to say that, the technology worked that well, that quickly. So, absolutely, thank you for that, and thank you for, bringing that information to us here tonight. Uh, I guess the next place to go with that information is because of how effective it was against Staphylococcus aureus. What does that mean for other microorganisms? Is it effective against others, or how do you translate that?
Well, based on my previous expertise and like my expertise and previous experience, that if it is effective against the Staphylococcus aureus, and I told you that like why we chose the Staphylococcus aureus, it is a tough organism. So I have all the belief that it is going to work in majority of the organism. If someone try to put the another organism, I am sure that it is going to have some antimicrobial effect. In case of resistivity, like the microorganism has a great capacity to become like resistance against some kind of the antibiotics or technology. In that case, we have to evaluate, but most part this organism which we have tested is a representative of a good scenario of overall microbial world. So it can be very effective, I would assume, with other microbes too. And that's what we can just experience once you put the MCI in your living space or your office space. You will see some difference in terms of air quality, because that is definitely have a very I would say like a strong antimicrobial capacity or capability.
Wow. So, I mean, from my takeaway of that is that you're looking at a technology that you have the proven effectiveness on the Staphylococcus aureus, but from what I'm hearing you saying, that it should be working the same or very similar on other organisms like viruses, bacteria, mold, things like that, not just on the Staphylococcus aureus, but on all these other types of organisms.
Sure, that efficacy result may be different, but that definitely it is going to be inhibitory in capability, meaning it is going to limit the growth of the bacteria, mold, viruses, etc. So yes, it should be working across the board. It is a matter of like if you are interested in one particular type of organism and particular kind of scenario, then still this organism, this technology is going to work, because I said you that result indicated that in within 2 hours that was much superior or faster when I compare it with the natural sedimentation rate. So definitely it is going to bring some difference in the microbial or total microbial population.
Wow, I mean, when you think about some of the big names that are out there right now that people worry about, H1N1, as a virus, all of the different human coronaviruses that are out there under, the SARS, and then you're dealing with just regular noroviruses, Legionella, all kinds of stuff like that that affect people all the time, all over the world. I mean, this really sounds to me like it's something that has that sanitizing or killing property to it that should be effective against all of these different types of organisms. Not putting you on the spot
Yeah.
for that, but in general, that would be.
Yeah, in general, we have tested its antimicrobial capability with one representative organism, and the organism which we have selected is kind of giving you information that it is across the board, because as I said you that it is a tougher organism. So obviously the viruses are much simplified life form, because well, again, I don't want to give you the information that a lot of people doesn't understand, but the viruses sometimes behave as in a non-living entity, so
Right.
it is living versus non-living. Let's not go on that, otherwise the whole meeting time will be
I
invested on
understand.
that to explain. But because it's the point I'm trying to bring here is that it is a simpler form of life. So simpler form of life is going to be definitely impacted if more complicated form of life is being impacted by the technology. That's my analogy, in a very layman's term. I'm not explaining it scientifically, but if it is killing the tougher organism, killing the less tougher organism is no brainer.
That sums it up. Thank you for
Yeah.
that. Um,
Yeah.
for those of you listening right now, I'm sure you have a lot of questions, and we can try to deal with those at a later point. But you know, getting your, I guess, your appetite at this point going for more information. This is just the tip of the iceberg for what Dr. Sase is really able to provide. Um, I just want to switch gears here a little bit away from the MCI technology, which what you've given us is just fantastic information. I understand that you also have testing that you can now have us do for mycotoxins on surfaces.
Correct. And that's a wonderful technology for those who are not aware of mycotoxin. Let me give you a little information on that before we go any further on that. The mycotoxin, as the name indicates, just there is two syllable. One is myco, other is toxin. So the myco meaning the mycology, meaning the fungi or the mold in your very simple understanding. And toxin meaning the harmful chemical that is not good for your body. So the toxin produced by the mold or fungi is collectively called as mycotoxin. And there are several type of those toxin are known, and some of them also very prudent or very commonly reported from indoor environment if the place is contaminated with various kind of toxins. So mycotoxin is one of the toxin which we uh, test in the laboratory to find out that what is the concentration of that toxin and what type of chemical or chemical composition of that. So we are capable to do a mycotoxin called as tricosthene. This is the name of a mycotoxin, and that is very common among all the mycotoxin, especially from the indoor environment. So there are, as I said, you number of other mycotoxin, such as toxin by the aspergillus, toxin by the fusarium. So the toxin produced by the aspergillus is typically alpha toxin, so tricosthene is likewise produced by the fusarium, Stachybotrys, aspergillus, that kind of thing produce this particular toxin.
And the testing that we're able to do out in the field and send to a lab like yours, you can actually identify that and let us know if it exists on those surfaces.
Yes, the way that test work, that the user supposed to collect the sample from the surface or as a bulk material. So if you're trying to evaluate a surface, whether it is free from mycotoxin or not, all you have to do, you have to roll about 3 inches by 3 inches area wise, the square area, and then making horizontal and vertical stroke. You cover the entire area with a swab, with a sterilized swab, and then that swab come back in the laboratory. That is also an acceptable sample, but mostly what people do, they collect the bulk material. For an example, 1 gram of dust, or maybe 1 gram of building material, or maybe you can collect dust out of your filtration system, or filter, or your ductwork. So whatever the material you can think that have the mycotoxin or suspicion to have the mycotoxin, you can collect. And if you don't find anything, you can just scrap it with your just have a protective gear. I highly encourage to have the PPE, because you never know that what is the concentration of the mycotoxin, and that is the one of the very important and crucial point that you understand. Whenever you collect any kind of environmental sample, you should prevent yourself from the exposure, because you never know whether that particular toxin is there or not. So just a pair of gloves and will do, and then you can take a sharp objects such as knife and etc. Just clean it with the alcohol, and then you kind of scrap the material. Or if you want to collect with the regular household vacuum cleaner, make sure that you clean it very good. And then something, if you need, we can supply that. It called as like dust sock, like it's a very like a bag made out of a special polyester material, and then you can just vacuum out those dust, and then you can send it to the laboratory. It should be typically 1 gram is the requirement, but little more or little less is okay. And if that thing come in the laboratory, we can go ahead and do this test. We utilize a technology called as ELISA, enzyme linked sorbitol assay. That's the name of the technology. And by which what we do, we run your sample against the known standard, and that's how we find out that what is the concentration and type of mycotoxin in the submitted sample.
Cool. Well, all of this is just more weapons in our arsenal, for going out there and helping people with indoor air quality problems, which is the
Correctly.
big umbrella under surface and air contamination. But all of this stuff that we've been talking about is really great, and this is stuff that hopefully our members and people listening will be taking advantage of. But I hear you have another piece of weaponry for us, that you also have the ability for us to test surfaces for the SARS-CoV-2 uh, organism.
Correct. That's the if I'm not mistaken, like last March, everybody start all of a sudden, in a raging mode, oh my gosh, what is going to happen? And they were not kidding around, they were not joking. So I was also one of the person, because while people were thinking about the clinical management or clinical diagnostic of the SARS-CoV-2, which is responsible for COVID-19 pandemic, my eye was on the environment, that what are the possible way that this SARS-CoV-2 is spread through the environment. And World Health Organization has several times mentioned that it is formite is one of the mechanism or the method by which it get transferred from one patient to the other, or transferred through the environment. So there was no, that was beyond the reasonable doubt that they were thinking that the formite play a very important role. So being in the field of environment, I start thinking that how I can figure it out that the formite is actually containing the SARS-CoV-2 virus. And that come in the head. And back then, believe me, there was very few people even was aware of the antibody exists for this, or antigen is there and it is going to cause problem. But I figured it out, because SARS-CoV-2 is not a very new virus for the mankind. It was reported much back before in the history. But the problem was that how we are going to recognize, how we are going to identify. So the PCR, this is the technology, polymerase chain reaction, come in picture, because it's a very nano particle, like a viral particle, and that has lot of implication. First of all, the size range. Second of all, how you clean those things, sorry, the collect the sample, and then how you clean. That was the main problem or main objectivity here. So I come up with a solution, that what if I test the surface and figure it out that whether it is the virus is present there or not, and that will help the dweller or the occupant to just make that surface clean, because the clean part comes later. Before, if you don't know what you are treating, you are never going to have the right medicine. So with that approach, I thought, first we need to make sure that we should be testing and letting people know that the surface is contaminated or not. And make long story short, I have come up with that solution. and the technology is called as RT-qPCR. And it's a very simple, again, I'm not going in the detail, the technical detail, because it will take me like, almost at least 5-6 hours to explain that how it is going to work. But all the end users supposed to collect the sample, again, you can use a swab, which is especially design swab. So it's not going to work with the cotton swab, which is like, sell in CVS or Walmart or any other drugstore. But this is a very specific type of swab because we are testing here the virus. So they are very, very like, picky, in other words. So we supply all the material, or one can find the material is called as buffer, like DNA and RNA free water in which the swab is dipped so that there is no previous contamination loaded on that piece of swab. And then you collect the sample. Afterward, on site where you are collecting the sample, you have to do something called as lysate. There is another solution that is called as lysate. So your swab need to transfer in the lysate, and then you can just like, back and forth through it and extract all the liquid from your swab in the lysate solution. And then this lysate solution is basically, or the vial containing the lysate solution, come to the laboratory, and we can extrapolate the collected like, gene. If there is present in that, then we are going to multiply it by using polymerase technology, and based on that we are going to identify, or we identify on routine basis, that whether there is a contamination of SARS-CoV-2 on that surface or not.
Well, again, more exciting news and technology that's out there for us to be able to go out and perform the services that we do now and get a more of a comprehensive profile of the indoor environment, of the air that people are breathing, what's going on the surfaces. I mean, this is all amazing stuff. And I do have to
Yeah, and
thank
then one more thing, it takes like, not too much of time, because the RT-qPCR technology is a very smart technology, and you can expect the answer within few hours turning the sample to the laboratory. Typical turnaround time for these, for the like, the testing the SARS-CoV-2 virus is between um, 24 to 48 hours. But only one limitation you have, that like your sample must be transited to the laboratory in a very fast manner, and we encourage to do the transit of the sample between 24 to 48 hours, but it can be a transit to the laboratory up to 72 hours. So your sample which you collect in the field must be deposited to the laboratory within 72 hours. Otherwise you have to make a special provision to preserve the sample. The sample is not going to be totally best, but if you are like, not capable or not in position to ship it, then you have to have a special protocol to preserve the sample where you have collected. And then there is a special protocol by which you can just transfer the sample from a place where it is collected to the laboratory.
Well, it sounds like you just created a lot of work for us, coming up with a new training to make sure our members know how to do this type of testing that they want to do, which is great. It's something that we can look into doing and being able to provide that training for our members so they can actually go and perform these services. What I was starting to say before was I wanted to thank you for, I'm going to say, simplifying the testing, the results, and everything else that you presented tonight. I could see how this could become extremely deep and involved with all the technology that you're using and the methodology to look into these microscopic organisms. I mean, and that alone is something that some people have such a hard time wrapping their mind around, how tiny these things are that you're actually looking at, and how you're getting all this information and data from that. So I just wanted to thank you for making it where it's understandable for us to be able to move forward with this, and now to try to look into possibly some more specific training.
Yes, and that is my privilege to be here today. And I tried to simplify it because I don't wanted to use the jargons and things like that. So I think that I have numb it down so that everybody can understand, because I'm not expecting everybody to be a microbiologist. It is a good that you understand that. But for the general mass, that is the concept. And if this is beneficial for the society, why don't we do that? And your members, I have heard that they're great to helping like, people to manage their indoor environment, because especially during the time of pandemic, this might be like, one more thing we have to do. So this is going to be like in our day-to-day life, that is one more thing we have to do, like we do make our routine for certain thing now. Do not ignore, because this is like some serious challenge. So air quality is gain some like very importance in our life, because we need to have like air uh, clean and pure. And I also work through like a lot of organization we work through. I'm also currently the vice president of Pan American Association of Aerobiology. We also distribute this thing through the American Society of Microbiology. I'm also a member of American Mycological Society of America. So all these society nowadays try to figure it out to help people to disseminate the information, so that a well-informed person can make a well-informed decision, isn't that?
Absolutely. We talk about in our world, we use a very simple saying that our technology, our methodology, the things that we do are really for people that like to breathe. That's really what it comes down to, which is about
Correct,
7.5 billion people, at the moment.
correct, correct.
So yeah, I really want to thank you for taking the time for doing this interview with us. I think it was tremendous, the information you gave us. It's exciting, the results of the testing that you did for us on the MCI technology and with the other testing that's available out there for the SARS-CoV-2 and for mycotoxins on surfaces. Again, a tremendous amount of information you gave to us, and the ability to do more testing to help our clients and the general public with specific needs. I mean, this is just what we're looking for. So I want to thank you for that.
Again, it's my privilege, and anytime if any of your member or you have some question, I'm always open. I'm pretty sure you can supply my email to your members, and if should they have any kind of clarification, they want to know some testing protocol, etc., for collecting or how to collect the specimen from air, surface, liquid, or water. I'm always here. I'm always willing to help. Okay, and again, thank you very much. It's my privilege to be with you all to evening.
Thank you again. And we will look forward to seeing you again on a follow-up to this. So again, thank you and take care.
Take care. Bye.